is infinity, then no. Okay. So we have two different situations. Limits that have the answer, that have an answer plus or minus infinity. Okay, so that's one possibility. So that's this. These are the infinite limits. And the other possibility is limits at infinity. And this is exactly what I wanted to write here, not that. I just got carried away. So limits at infinity. I was thinking of reminding you of these two types, not to get confused, and that's exactly what I did. I wrote the other one. Okay, so limits at infinity. This is section 2.6. Now, this is what I wrote there, infinite limits. And I want to give an example. And we had examples like limit as x approaches 5 from the left from 1 over x minus 5. Can anyone tell us what this equals to?
It'll be undefined, or does not exist. Sorry.
Okay, so let's review something important. A number divided by 0 is not DNE. Not.
Indeterminate case.
No. A number divided by 0 has three possibilities: positive infinity, negative infinity, and DNE. I didn't want to write this. It's not undefined. I'm having problems with words tonight. Keep me on the right track, please. So it is correct when you said that a number divided by 0 is undefined, but we are not talking about that. You can say it's undefined, actually, but this is not what we are talking about. When we talk about limits, we do not have the concept of undefined when discussing limits. Yes, a number over 0 is undefined, but we are not talking about undefined when discussing limits. So this situation is from our past experience. So we should not, we should not have difficulties with this. And the answer is
negative infinity.
Thank you very much. It is negative infinity, which automatically means that x equals 5 is a vertical asymptote. Any questions about this? Since only Brian answered, anything, anyone? Any questions on this?
I just want to check if it was to equal a positive infinity, it would also be a vertical asymptote, right?
Any situation like this, either positive infinity or negative infinity, this is a vertical asymptote.
Okay, good.
Even if it's just on one side and not on the other. Okay, other questions on this? Okay, this is from our past. This is not new. Now we want to talk about limits at infinity. See, this is different. Here we are going to say limit as x approaches infinity. Limits at infinity when x approaches infinity. Infinite limits when the answer is positive or negative infinity. Okay, so this is what we are discussing today. Limits at infinity. And let's start with an example. There are many situations. And let me refresh our memory on one more thing. Indeterminate cases. There are 7. For now, we do know 2. Actually, if I remember correctly, we also experienced this, but maybe not. I don't think we did. I think we experienced infinity plus infinity, which was infinity. Okay, so anyway, I listed for now 3 indeterminate cases. There are 4 more, and we're going to get to all of them. So this is what we are trying to find. If this is a number, then y equals this number will be a horizontal asymptote. If it's infinity or negative infinity, infinity or negative infinity, there is no horizontal asymptote. It may be a slant asymptote, or like this, but not a horizontal asymptote if this is not a number. But if it is a number, when x approaches infinity or negative infinity, then that will be the horizontal asymptote. So we're going to choose right now from any problems you want. I hope I get to choose too, if you allow me to. Okay, let's start with just an example here, and I think we looked at something similar a long time ago. As you see, as x approaches negative infinity, where do the function values go? Or where will the function tend to?
It tend towards positive 2.
Exactly, which means y equals 2 is a horizontal asymptote when x approaches negative infinity. What about the other side? When x approaches positive infinity, the function values approach
1.
Here it is. Let's follow the function. Negative 2. Y equals negative 2 will be a horizontal asymptote. Same thing here. Okay. I don't want to start with an example like this just now. I'm going to come back in a few minutes, and this is a very important type of problem for what follows in chapter 4, you will see. Okay, so this is very important. I'll come back to problems 5 through 10 in a blink. Okay, I want to look at problems from 15 through 42 first, and then we'll come back to the other 2. Allow me to choose the first one so I can explain what's happening here. Let's say I'm going to choose 19, and then you choose the next. So 19, limit. I'm going to replace r by x because it's easier to write. X minus x to the third over 2 minus x squared plus 3x cubed. There is a method that you will see in the book and maybe in other books. I caution you on that method of multiplying top and bottom. Okay, I don't like that. Yes, it's legitimate, yet yes, it's okay, but I'll explain the flaws of that method, and there are many. And especially, maybe not many, but one very important one. Okay, so x approaches infinity, and we have a function. What do we need to do first when we're asked to find a limit?
Simplify.
When we're asked to find a limit, what is the first thing that comes to our mind?
Usually we put the limit into
Excellent.
what x.
Excellent. We have to plug it in. So maybe I should write the steps again. Plug in. You can say, and I will agree, you're not allowed to, because x approaches infinity, x does not equal infinity or a or anything else. I agree, but we still have to do it. Okay, let's plug it in at the top. Which of these 2 terms is the most powerful one when we talk about infinity?
X cubed.
Good. So this one doesn't even count. So where does the numerator go? When x approaches infinity, where does this go?
To negative infinity.
Great. Again, the same silly question, just to make sure everyone understands. Which of these three terms is the most powerful when we talk about infinity? Because if I ask you evaluate for 0, you cannot disregard any term. If I ask you evaluate for 10, you cannot disregard any term. But we are talking about infinity. Which of these three terms is the most powerful, or will
So I
be?
have a question.
Yes?
Is that a 2 minus x?
Yes.
squared?
Yes.
2x.
Sorry.
Okay, thank you.
Better?
Yeah, but
Sorry about that. Okay. So which of these three is the most powerful?
3x cubed.
Right, is the leading term, no question. So where does this go when x approaches infinity?
Positive infinity.
Very good. So this is definitely, the sign, it doesn't matter. So definitely this is an indeterminate case, infinity over infinity. There is hope. For any indeterminate case, there is hope. This is the only one that does not have any hope. A number over 0. No hope whatsoever. But all the 7 indeterminate cases, I'm not saying that the limits will exist. No, I'm only saying there is potential. They may. Okay,
I have a
perfect.
question.
Yes?
For the indeterminates, sign doesn't matter?
No.
Okay.
No. Infinity over infinity or negative infinity over infinity doesn't matter. Same thing. Very good question. Okay, perfect. So here's how we analyze the next, or how we proceed. I'm going to write here, of course, because as you know, I always run out of room. Okay. Can anyone tell us? And I just remembered to tell you something, and I'm going to write it here so I don't forget. Limits. I saw something in your written homework that I need to address. Okay, I just remembered. Okay, so limit as x approaches infinity. Let's go back to the numerator. And you correctly identify the leading term in both. So then again, I'm going to ask, what is the degree of this polynomial?
It would be 3, right?
Very good. We take out the degree. Stop, because I need to explain. If I have 4x minus 7, can I factor out, let's say, silly, x squared?
No.
No. But unless I do this. What's all this? I came up with something such that when I multiply by x squared, I get this. So now they are correct. Left-hand side equals the right-hand side. X squared times 4 over x, I simplify an x and I get 4x. X squared times negative 7 over x squared, I simplify x squared and I get this. The point I'm making with this is that I can factor out anything I want from anything. So from, let's say, from 100, can I factor out a squared? Yeah. So I can do whatever I want. I can factor out whatever I want, as long as this quantity multiplied by this gives me back the original problem. So coming back here, yes, I can factor out x cubed as long as I'm very careful with respect to what I write in here. The denominator has also degree 3. I can factor out whatever I want from whatever I want, as long as whatever I write here and distribute x cubed, I recover the original step or the original problem, and the same thing here. So can anyone tell us what to write? It's okay if you're wrong.
1 divided by x squared minus 1.
Perfect. Because x cubed times 1 over x squared is x. And x cubed times negative 1 is x cubed. And you gave me 2 terms because that's what we had. How many terms will you give me in the denominator? Anyone else?
3.
Exactly. Can anyone give us those 3 terms?
X squared divided by x cubed.
You mean 2 over x cubed? Yes.
X cubed. Mhm.
Good.
And then minus x squared divided by x cubed. Because it's going to cancel, right?
You mean 1 over x. And then plus 3. I'm not sure what you said. X cubed times 2 over x cubed is 2. X cubed times 1 over x is x squared. X cubed times 3 is 3x cubed. I'm not sure if you said that. Then yes, I'm sorry. I didn't understand.
No, that's not what I said.
But if you did, I apologize. I just didn't. Okay. Is this clear to everyone? Okay, what do you think I'm going to do next?
We cancel out x cubed.
Of course, absolutely. And now let's analyze what happens next. Stop, because I need to explain one more thing. We did look at the graph of 1 over x. And now I would like to determine this. So let me refresh your memory. This should be very vivid in our memory. So we don't have to go do this again. It's not a mistake. It's not a problem. But we should pass this already.